The next step up in complexity is to first predict the charge on the ions and then determine the formula unit of the ionic compound. We see sodium, 1A, 1 valence electron. It's going to go to sodium plus. It loses that 1 valence electron. Oxygen, 6A, it gains 2 electrons to go to 2 minus. So the formula of our compound is Na2O. Let's consider what's happening. We have 2 sodium atoms. Each sodium atom gives up 1 electron to oxygen, so we have 2 atoms giving up each 1 electron, so oxygen accepts 2 electrons from the sodium. Now we have a sodium plus cation that's going to be attracted to an oxide ion, O2 minus ion, and this is how we form the ionic compound. For aluminum chloride, we have aluminum, 3A. It's going to lose its 3 electrons to form a 3 plus charge. 7A chlorine has 7 valence electrons. It accepts 1 more. So we have an aluminum 3 plus ion, a chloride minus 1. So we need 3 times as many chlorides as we have aluminum. We're going to practice recognizing the ions that are present in an ionic compound. There are a number of different types of chemical problems where we have to be able to do this. You may have noticed that in the formula of every ionic compound we've looked at, the cation is written first in the formula. The cation is written first, followed by the anion, the cation and the anion. And this is a general rule. When you look at the formula of an ionic compound, the cation is always written first. Calcium we've learned to recognize as a 2A metal. It's going to form a 2 plus ion. Sulfur is a 6A nonmetal. It's going to form an 2 minus. Magnesium is another 2A metal. Very quickly as you practice these problems, you'll begin to recognize the most common elements. Magnesium, 2A, going to be 2 plus. Fluoride is a 7A element, so it's going to be an F minus ion. 7A element, 7 valence electrons. It's going to accept 1 electron to go to an F minus ion. Cesium is a less common 1A element, but it's 1A. It's going to form a plus 1 ion. And oxygen, we know, is 6A and typically forms 2 minus ions. Identifying bonding in different compounds. In this first example, we see that there's a metal, magnesium, plus a nonmetal, chlorine. That makes this an ionic compound, and the bonding that exists is ionic bonding. CO2 is a molecular or covalent compound. It's a molecular compound, which means the bonding that exists that's holding these atoms together is covalent bonding. Here we have some potential confusion. Hydrogen is typically shown in 2 different places on the periodic table. It's often shown here at the top of column 1 and also at the top of column 7. So where does it belong? Is it a metal? Is it a nonmetal? In most every circumstance, hydrogen is considered a nonmetal. Therefore, H2S is a molecular compound, and the molecular compounds held together by covalent bonding. In our last example, we see an ionic compound that contains a polyatomic ion. Remember, polyatomic ions are a group of atoms that are held together by covalent bonds. So there's covalent bonds holding the atoms within the polyatomic ion together. There's ionic bonding between the barium 2 plus and the carbonate ion. These type of compounds contain both ionic and covalent bonds.